the last video clip of the first order logic. Uh, Guys, look at this example. You have to think about how can we transform the sentence into the first order logic. Example. Okay. Uh, for example, if we would like to transform the knowledge like there is some dogs, there are some dogs, sorry, there are some dogs that or who can run faster than all rabbits. There are some dogs that can run faster than all rabbits. Okay, there are some dogs, so the main connectives must be for some, right? For some dogs like this. If sorry, for some y, and y is a dog. Yeah, there are some dogs that can run faster than all rabbits. Faster than all rabbits. What does it mean? For all x, if x is a rabbit, then faster y and x, right? Faster for all x, if x is a rabbit, y is faster than x. So the main connectives for some must be and, right? Cannot be if then, cannot, right? So if you can find a dog that faster than all rabbits, this sentence will be true, right? There are some dogs that can run faster than all rabbits. So this sentence can be used to represent the concept of there are some dogs that can run faster than all rabbits. And someone may think that, okay, can we do something like this? For all x, if x is a rabbit, for all rabbits in the world, if you are a rabbit, then there will be a dog that is faster than you. Slightly different, right? And what is the meaning of this sentence? Is it same as this one? No, it's not the same. Slightly different. You can think that if x is a set of a, b, c, and y is x is a member of set a, b, c, and y is a member of x, y, z. The first sentence means that if you can select one of them, just one x or y or z that is faster than all a, b, c, the first sentence will be true. But how about the second sentence? It can be true if x is faster than a. and B and C is faster than B is faster than C. This sentence will be true if you can find some, for example, X or Y. If Y is faster than C, is it okay? So it's different, right? Slightly different. For the first sentence, all here, all dogs here must be the same dog. But for the second sentence, these three dogs can be different. Can be X, can be Y, can be Z. We need only one thing, that is, this one must faster than this one. This one must faster than this one, and this one must be faster than this one. So this is like one example. Very a little bit difficult, right? So guys, now we will use another example that comes from the WUMPUS world. So guys, from the WUMPUS world, for example, I would like to remind you again about the condition of the WUMPUS world. If this is a pit, all adjacent cells must be breezy, right? If we'll talk about just only pit and breeze, you can use this knowledge to apply to the concept of WUMPUS and smelly also. But if there's a breeze here, it must be some grid that adjacent to this grid that is a pit. Like breeze, this is pit, this is breeze, this is pit, or maybe you can like this is pit or this is a pit. Okay, so there must be at least one adjacent grid that is a pit. So how about the rules? Can you write the rules of WUMPUS? Okay, let's pause the video and try to think by yourself using this example. Okay, let's pause the video, and once we come back, you will see the solution. Okay, so for this situation, we can write the rule to represent the knowledge of this condition. That is, for all x and y, if y is a pit, and adjacent, sorry, I would like to reformat the cell. Okay, this is the benefit of using iPad. You can rewrite and it easily, if it you can edit it easily. Adjacent x and y, then it breezy y. Oh, sorry, breezy x I'm sorry that I think if I write it in this way, it must be easier for you. For all x, for all y, if x is a pit and y is adjacent to x, then it must be y must be breezy. Okay, so this is the first knowledge that you can write. And how about the knowledge here? How about the knowledge here? For all y, if y is busy, if y is busy, then there must be some x that is adjacent to y, and x is a pit. Okay, can you see? I'd like to share this sentence. This is a small sentence. Can you see that for the main connectives in this case we use for some, right? For some we use and for this scope, for all y, breezy y, breezy y. Can you see? We use if as the main connectives, but for some here in this case, for some x in this sentence we use and as the main connectives. For this sentence we use for all x and y, and we use if as the main connectives. Okay, so this is some example that you should study and be able to represent the rules in the first order logic. So this is the end of the introduction to the logic. In the next session, you will study how can we do the reasoning, try to find the new clause that can be concluded from some given knowledge base. Guys, see you in the next session.